Today I'll explain what is ultrasonic sensor and how the ultrasonic sensor, what is the working principle of ultrasonic sensor and how to measure the distance using ultrasonic sensor. So ultrasonic sensors are the devices that use sound waves. The sound waves frequency are typically above 20 kilohertz. So these sound waves are used to measure the distances, and these sound waves are used to measure used to detect the objects and to perform various tasks. And these sensors are widely used in many industries and applications due to their reliability, accuracy, and non-contact nature. And there are some important components in an ultrasonic sensor: transmitter, receiver, and controller, and display or output. So we use the ultrasonic sensor in most of the IoT experiments to interface with the node MCU. So this module is used. The module number is HC SR04. So it has got 4 pins: VCC pin, trigger pin, echo pin, and a ground pin. So how to use this, and what is the working principle, that I'll explain now. So in key components, it has got a transmitter and a receiver. And the transmitter emits the ultrasonic pulses into the environment, whereas the receiver detects the reflected sound, reflected sound waves. So some of the applications of ultrasonic sensor, they are used in robotics and automation to detect the obstacles and measure the distance to the object. They are used in automotive applications to assist drivers in parking by providing distance information. And they are used in industrial setting to measure the liquid levels in the tank or liquid levels in the containers. And the ultrasonic sensors are used to detect the presence or absence of objects on the conveyor belt, whether the object is present on the belt or absence of the object on the conveyor belt, that is detected with the help of the ultrasonic sensor. And in fluid flow applications such as water flow measurement in a pipes, for that purpose ultrasonic sensor is used. And in medical imaging system, like they are used in medical ultrasound machines for imaging internal organs and tissues. So these are the few applications I have listed. So now I'll explain the working principle. So the ultrasonic sensors, they are based on the principle of sound reflection. So they are based on the principle of sound reflection. They consist of a transmitter and receiver. This is a transmitter and this is a receiver. So it consists of transmitter and a receiver. The transmitter emits high frequency sound waves, that is frequency above 20 kilohertz. So this transmitter emits high frequency sound waves. So it is marked here. So it produces sound waves, and they are referred as ultrasonic pulses, which travel through the air. They travel through air, or they travel through some medium such as water. So till how much distance they travel? They travel through the air or water till they encounter an object. Assume this is your object. So it keeps on moving till it finds an object. When sound waves strikes an object, or when the sound waves hits the object, it gets reflected. The sound waves get reflected back towards the sensor's receiver. First, it goes from transmitter and it hits the target, and the reflected wave will come back towards the receiver. The receiver then detects the reflected waves, and then the time taken for the wave uh, to return, it is used to calculate the distance between sensor and the object. What is the at what distance the object is present? This distance is calculated with the help of the time. The time taken for the wave to travel from transmitter and go and hit the object and come back towards the receiver. What is the total time taken from the transmitter and after hitting back received from the receiver? So this much time is measured, in this much time is calculated in order to find the distance of the object, and the distance is calculated with the help of the formula. We know that velocity is equal to distance by time, and velocity is equal to distance by time. So distance is equal to velocity into time. Here the velocity is considered as a speed into time, and it is divided by 2. Why it is divided by 2? Because it is the waves are traveling, the distance of the object is only from this much to from here to here, but the wave is going from transmitter towards object and from object back to the receiver. So it is traveling 2 times. So the time is 2 times the time we are considering. So for that purpose, we will divide the formula, the speed into time divided by 2 we will do to calculate the distance. Actually, it is time by 2. One time I should take, but for receiver to find the value, I have to take the total time and divide it by 2. Let us assume you have an ultrasonic sensor connected to the microcontroller, and you want to measure distance of the object using this sensor. So here I'll give one example. To find out the distance, I need the speed of the sound and the time taken from here to here and come back to here. So 2 parameters I need. Let us assume the speed of the sound in the air is given by approximately 343 meter per second. So this is very, very important parameter to find out the speed distance. The speed of the sound wave is 343 meter per second. In terms of centimeter, how much? So in centimeter, it becomes 343 meter. 1 meter equal to 100 centimeter. So total how many centimeters it becomes? 343 into 00. That much meter per second. I'll show you. 343 into 100 centimeters. That is equal to 34300. That is centimeter. So here I'll copy this and I'll paste here. So 343 meter per second is nothing but 34300 centimeter, and it is always taken in a ultrasonic sensor per microsecond, not second, because the standard value of the sound velocity is 343 meter per second. But during calculation, we consider it as a per microsecond. So what is microsecond? The value what I have taken, 34300 centimeter divided by microsecond. Microsecond means 10 to the power of minus 6. So if I do this, I'll get the value 0.0343 centimeter per microsecond. So this is centimeter per microsecond. So this much I have to calculate first. Then to do all these things, first we should trigger the sensor. So send a trigger signal to the sensor to initiate the measurement. The sensor emits a burst of sound waves. So it emits the sound waves. So where it is shown, see, when I give a signal to the ultrasonic sensor, the transmitter, when I activate the trigger pulse, there are 2 pins for ultrasonic sensor, trigger pin and I'll show you trigger pin and a echo pin. Where is it? Trigger pin and echo pin. So when I give signal to the trigger pin, so what it will do? It will start emitting the sound waves. So that is the meaning of send a trigger signal to the sensor to initiate the measurement. Then the sensor emits a burst of sound waves. So when it emits the sound waves, to measure the echo signal, so when it starts emitting the first echo pulse, you should start a timer. So the start a timer as soon as you send a trigger signal, and measure the time it takes for an echo signal to go from low to high. So when you send a signal, it go and hit the object, and after that it will come back to the receiver. So that time the echo signal will go from low to high. So let us say that the measured time is 590 microsecond, the time taken by the signal to go from transmitter to object and from object to receiver. Let us consider that is 590 microsecond. So to calculate the distance, since the sound wave is traveling to object and back, we need to divide the measured time by 2. So because I want to get one-way time, not two-way time, so divide the time by 2. So one-way time, how to calculate? So I have considered the example 590 microsecond for both way. So that you divide it by 2, I'll get to 295 microsecond. Now to calculate the distance, I have a formula. Distance is equal to speed of the sound into one-way time. This is very, very important. So what is the speed of the sound we have calculated in terms of microsecond? That is 0.0343 centimeter per microsecond. And what is the one-way time we got? We got it as 295 microsecond. So after multiplying these two, I'll get the value 10.1085 centimeter. So in this example, the calculated distance to the object is approximately 10.11 centimeters. So you should keep in mind that the actual measured distance may vary based on the specific conditions and the accuracy of the sensor. So it depends on both the terms. And in this, I have used the module number HC SR04. It is an affordable and easy to use distance measuring sensor. And how much distance it can measure and what is its range? So its range varies from 2 centimeter to 400 centimeter. This much distance, within this distance, if you have an object, it will identify that object. In terms of feet, from an inch to 13 feet. So that much distance this is able to measure. So that is about the HCSR04. So assume for HCSR04, you are making the trigger pin high. So the trigger pin, when you make high for 10 microsecond, then it starts producing the sound waves. So the how many sound waves cycle it produces? It produces 8 cycle sonic burst. So these these waves start traveling from transmitter to receiver. So till that time, the echo signal will be low because it has not yet received any echo signal. When it go and hit the object, the echo signal will come back and it will reach the receiver. As soon as the echo signal reaches the receiver, the echo signal go from low to high. So the time taken by the sound wave to travel from transmitter and till the echo signal goes high, that much time is measured and it is divided by 2 in order to get one way time for the calculation of the distance. So this is all about ultrasonic sensor HCSR04 to measure the distance of the object, and this is very useful sensor in IoT applications. Thank you for watching this video.